Right, yesterday we worked with midpoints and distance between 2 points and a two-dimensional set. Had a worksheet that dealt with the distance and midpoints. Wasn't very difficult to do, should not have been very difficult to do. Solutions, once again, as we talked about with respect to distance, solutions should be in a radical form. I do not want decimals with this, I want a radical form. So leave things in radical form, simplify your radicals. Once again, just like you're simplifying fractions, simplify the radicals down. Questions you have about any of the problems on here? Once again, solutions are provided for you to be able to check your answers. So we're not going to go through unless we need to. We're not going to go through problems here in class. If you need to go through problems, we'll do that. Okay. Then we're going to start continue on with the idea of functions. So work with functions and equations of lines. Today we're going to talk about symmetry, the idea of symmetry, odd and even functions. Talk about the x-intercept, we'll talk about y-intercepts today. This entire chapter, chapter 2, deals with coordinate planes and the idea of functions and working with the idea of functions. Once again, we've dealt with this in algebra and dealing with the idea of functions. We have two specific types of functions with respect to classifications of these types of functions. The first type is an even function. When we talked about an even function, opposite values from the domain, and we talked about this in trig class. Remember back to trig class, we talked about sine and cosine. When we talk about an even function, opposite values from the domain, opposite x values, these are domain values. Opposite values from the domain will result in equal y values or range values. Opposite values from the domain will result in equal values from the range. This is called an even function. If you have to go get pictures, just go. Don't have to ask permission, just go. When you talk about an even functions, opposite values from the domain will result in equal values from the range. If we take a look at ordered pairs, you have x and y. Negative x will give you the exact same y value. So you have an x and a y. If you have some value of x and you get a value of y as a y value, as a range value, and you put in negative x, you're going to get the exact same y value. When we talk about an odd function, opposite values from the domain for an odd function, you put in opposite values from the domain, what you're going to result in is opposite values from the range. Opposite values from the domain will result in opposite values from the range. This is called an odd function. Equals give you even function. You can think, you can correlate all the e's together. Odds give you opposites, which gives you an odd function. Opposites give you opposites, that's an odd function. The O's match up. and there's going to be symmetry about the origin. When you have an even function, you're going to have symmetry about the y-axis, which means symmetry, you're going to get a mirror image. Whatever you see on one side, you get on the other side of the y-axis. It is a mirror image. When you're symmetric about the origin, you're going to be equal distant from the origin in opposite quadrants. A true test, and this is what I will tell you to do with respect to a test for an even or odd function. Sub in an x value of 2. Sub in an x value of negative 2. Sub in 2, sub in negative 2. If you sub in 2, negative 2, then you evaluate what your y values are. Okay, so sub in, you don't do 1 and negative 1, because sometimes I will give you a false positive. Okay, don't do negative 1 and 1. Okay, but do negative 2 and 2. Sub in 2, sub in negative 2. Find what your value was, or calculate your y values. Once you find your y values, then you can sit there and evaluate. Okay, did I get opposite values for y, or did I get equal values for y? If I got opposite values for y, that's an odd function. If I had equal values for y, that's an even function. When I have an even function, I have symmetry about the y-axis. When I have an odd function, I have symmetry about the origin. So all these things sort of connect together in regards to the idea of symmetries and even and odd functions. Symmetry about the x-axis. You can have some symmetry about the x-axis. And this will result when opposite values from y, range values, will result in equal values from the domain. What relation?
I was taking some pictures. Sorry.
We have opposite values from the range, which are y values, will result in equal values from the domain, x values. Now, this is not going to be a function, and we'll talk about the idea of functions later. This will not be a function. But it is, we do have classifications in regards to characteristics of a graph. We can have some symmetry about the x-axis. Okay? What you see on one side of the x-axis, you see on the other side of the x-axis. It just won't be a function. We have 3 problems here. I want you to classify as odd or even, and then describe the symmetry. And once again, the test, what you need to do in regards to a test. You're going to get 2 different y values. Sub in x equals 2. Sub in x equals negative 2. What do you get for the y value? Sub in x equals 2, sub in x equals negative 2. What do you get for y? And then classify, what do we have? Do I have an odd function? Do I have an even function? Or is it neither? It may be a neither. Then describe the symmetry for each one of these. Check your answer with somebody around you. Sub in 2, sub in negative 2. Watch your negative signs. Okay, once again, it's big boy, big girl mathematics here. I'm taking negatives to an exponent. I need to make sure I get my negatives to an exponent. Do all three of them. There's three problems there. Do all three of them. 7, 2, 7, -2. What do you get for y values? Classifies it odd, even, or neither. And describe the symmetry. What's our symmetry look like? You can check your answers with somebody around you. First one, what do we get? X equals 2, x equals -2. Emily, what do you get from y equals x equals 2? What's y equal? And x equals -2, what do you get? -11. So I get put opposite values for x in, I get equal values for y. Okay, so this is going to be what, Emily? An even function. If this is an even function, when we have an even function, we're going to have symmetry about the y-axis. Once again, you really have to watch your negatives here. Okay, we're taking exponents. Taking exponents, we have negatives. Okay, x equals 2, x equals -2. Q, what do you get? X equals 2, what's y equal?
9.
X equals -2, what do you get?
-7.
-7. So, odd or even? Neither. It's neither. I put in 2, I put in -2. I don't get equal values, I don't get opposite values. Once again, need to watch our negative signs here. Okay? I have 2 cubed, which is 8, plus 1, that gives me 9. I have -2 cubed, that gives me -8. -8 plus 1 is -7. Last one, x cubed plus x. What do we have? Courtney, what do you get from y? I'm sorry, what? And for -2? -10. So I put in 2, I get 10. I put in -2, I get -10. I have 8 plus 2, which is 10. I have -8 plus a -2, that gives me -10. So this is going to be what? This is an odd function. So our symmetry is going to be what? It's going to be about the origin. Once again, the mistakes is not probably the application of the definitions that we have here. The mistakes that may have occurred as you go through this is with your calculations in your calculator. My suggestion to you, whenever you deal with the negatives, you put quantities around that -2 cubed. or minus a negative 2 to the fourth. Make sure you get parentheses around that to eliminate some mistakes for you. X-intercepts. We talk about x-intercepts. It's a point at which a graph crosses the x-axis. The point at which the graph crosses the x-axis. This is called an x-intercept. At that point, that's where y is equal to 0. Your x-intercept is the point at which a graph will cross the x-axis. The value we know is true at that point is y value is equal to 0. And the y-intercept is exactly the same, except for it's where you cross the y-axis. And that's where your x is equal to 0. So your y-intercept is the point at which the graph will cross the y-axis. It's called an intercept. So you have the x-intercept, the point at which a graph crosses the x-axis, where y is equal to 0. And the y-intercept is the point at which a graph crosses the... it should be an x-axis and y-axis, my bad. That's what I get for copy and pasting. That should be a y there. Y-intercept, the point at which graph crosses the y-axis, my bad. And that's where the x value is equal to 0. Got two equations down here. How we solve for the x and y axis? I could sub in. My y value is 0. What does x equal? My x value is 0. What does y equal? Go ahead and calculate your x and y intercepts. Calculate your x-intercept, calculate your y-intercept. How I calculate my x-intercept? I put y equals 0 in, solve for x. How do I calculate my y-intercept? Put x equal to 0 in, solve for y. Check your answer with somebody around you. The nice thing about the zeros is when you sub in zeros, things go bye-bye. Okay, if I put y equals 0 in, I have negative 3 times 0. That just gives me 0. Just gives me 2x equal to 9. So when I solve that, Alexa, what do you come up with for the x-intercept here? First one. 9 twos or 4.5. It does not matter. Second one, I put 0 in for x, solve for y. What do we come down to, Justin? Negative 3. That's correct. Okay, once again, x equals 0. This goes bye-bye. I have negative 3, y equal to 9. Divide both sides by negative 3. Next one, x-intercept. Y equals 0. I get y equals 0. Callie, what do you come down to? X equals negative 1, x equals 3, because we have 0 is equal to x squared minus 2x minus 3. Okay, this puts us right into a quadratic equation which we have solved. Okay, we have solved this. So we factor down. Our two factors for that is x plus 3, x minus 1. So we get the values of, do we switch the signs? Yeah. Should be a positive 1 and a negative 3. There we go. That looked a little better. Now, if you think about what we have with respect to a quadratic equation is a parabola. Okay, so it's going to be a U. You're going to intersect the graph at two distinct points, or the x-axis. Second one, x is equal to 0. Put 0 in for all my x's. Well, what do you get for y? Y equals negative 3. That's correct, because these go away, so we just have y equals negative 3. Okay, so we have odd even function, we have symmetry, now we have x and y intercepts that we're going to be dealing with. This section sort of is a hodgepodge of ideas. Also throws in some ideas of a circle. Once again, I don't know why. It's just how the book is designed. Throws in the idea of circles. So we'll look at the idea of circles. By definition, when you're back in Dr. Clark's class and you're going through geometry, by definition, what we had with respect to a circle is a set of coplanar points. A set of coplanar points, which means you're on a plane. Coplane. That are equal distance to a given point. A set of coplanar points that are equal distance to a given point. That was our definition of a circle. A set of coplanar points equal distance to a given point. Once again, as I've talked about and alluded to many times in mathematics, mathematics always goes back to definitions. How are things defined? And from that point on, we're going to then do mathematical computations on how things are defined. Circles, a set of points, coplanar points equal distance to a given point. The center is that given point. Whatever that given point is, that's your center. The radius. Once again, by definition, what the radius is, it is a segment. It is a line segment, which means you have to have two endpoints. If it is a segment, you have a beginning spot and an ending spot. It's a segment with one endpoint at the center of the circle and the other endpoint on the circle. So you have a center, which is the given point, And then the radius is a segment. Okay, it is a segment with one endpoint at the center of the circle and the other endpoint on the circle. And once again, this is by definition. But what we always refer to, it's the distance from the center point to the circle. That's technically the length of the radius. The length of the radius is the distance from the center point to the edge of the circle. Now what we get to refer back to is we refer back to what we talked about yesterday. Yesterday we talked about two different topics. We talked about a midpoint and we talked about the distance between two distinct points. And we talked about the distance between two distinct points. Our distance formula was d squared is equal to delta x squared plus delta y squared. Okay, it's what we talked about yesterday. And when we talked about, once again, the delta x and the delta y is the subtraction of the two x values, the subtraction of the two y values. Okay, whenever you talk about delta x, when you talk about a delta, you're subtracting the two values. That gives us a distance between two things. Whether it's between two temperatures, what is my change in temperature? I go from 10 degrees, I go to 30 degrees. I've changed my temperature 20 degrees, 30 minus 10. Okay, I subtract my two values. And then we talked about yesterday mathematically, there's different things that you can do with regards to absolute value, and think about your origins or a zero, distance from zero, and then add values together. There's all kinds of different mental madness things that we can do. But mathematically, what's a little bit more accepted when I talk about my delta x, delta y, is when I'm talking about delta, I'm subtracting values. So d squared is equal to delta x squared plus delta y squared. Well, if I take a look at a circle, here, okay, I have some point x, y, and I have a center. This is my center. There's my egg. This is somewhat of a circle. There we go. That's horrible. Sort of a Stewie head there. Sideways Stewie. Sort of tilted sideways. But if we take a look, by definition, it is a set of points, set of coplanar points that will equal distance from a given point. Here's my center H and K. Here is any point X and Y that's on the circle. This is my distance, which is also, by definition, what we talked about up here, the radius. It's a segment with endpoint on the circle and at the center point. Well, if we take a look at what occurs here, if we look at our delta x and my delta y, my delta x is x minus h. That is my delta x, is my x minus h. Subtracting my two x values. My delta y is equal to y minus k. Once again, my center point is at h and k. My center point is given to me at h and k. So making some substitutions here.
with center point of the circle to HK. This distance turns into our radius. So we have radius squared is equal to my delta x squared, x minus h squared plus a y minus k squared. This is an equation of a circle with center point at HK. When we're talking about equations, once again, they are solution sets. They are solution sets that define every point on that circle. So if we take a look at the problem down here, name the length, name the center, and the length of the radius, and graph. So if I take a look, I'm looking at my center point is what is being subtracted from x and what is being subtracted from y. My radius, this is my radius squared. So if I take a look what's being subtracted from x and what's being subtracted from y. Austin, what do we have for our center point? 3 and negative 1, that is correct. You're looking at and you're asking yourself, what's being subtracted? Well, here the 3 is being subtracted. I'm good with this. Over here I have y plus 1. What's being subtracted? Well, if I do a little ching boom, this is y minus a negative 1. Okay? I have y minus a negative 1. So what's being subtracted is my negative 1. My radius, what's our radius going to be here? Sarah? Is a value of 3. So if I'm going to get a graph down, try to get a graph. Center point at x equals 3, y equals negative 1. So we have a center point, x is 3, y is negative 1. Trying to space this out as best as possible. From my center point, I could go up 3. I could go to the right 3. I can go to the left 3. And I can go down 3. From this point, it's a matter of making your Stewie head. I typically will put lines at my 4 points I put there, and try not to do a circle all at one time. I just connect the end points and try to make it as circular as possible. Not bad. If you don't space them out well, you're going to really get an egg. What's the equation of the circle with center point at negative 3, 7? And a radius of square root of 13? We have x minus a negative 3, which is x plus 3, quantity squared, y minus 7, quantity squared equals 13. Sorry, I rushed through that. I want to try to get to the last one here. Determine the center point and the length of the radius. Now, it's not in a basic standard form. But we need to be able to find the center point and the radius. So what we're going to do is we're going to group. We're going to group our stuff together here. My x's, I'm going to group them together. X squared plus 6x. Because if I take a look at my equation here, this x plus 3 quantity squared means x plus 3 times x plus 3. I have two identical factors of x plus 3. So what I want to be able to create is I want to be able to create that concept down here. but I have x squared plus 6x. What we have to go back to is what we did in the first chapter. The idea of completing the square. The y squared, we have nothing to tag along to the y squared, so I'm going to leave that alone, is equal to, I'm going to add my 16 to both sides, and go plus blank. Now we complete the square with respect to the x's. What do we add to both sides? 9. Okay, we're going to add 9 to both sides. Take your 6 divided by 2. 6 divided by 2 and square it, which is 3 squared. We get a value of 9. So what we do to one side, we do to the other. Now we have created two identical factors, hopefully. So we have x plus 3 squared plus y squared is equal to 25. Center point. What's your center point? What's your radius? We have nothing to subtract off the y, so what's our y value there? Right, so what's our y value going to be? 0. That's correct. Since there's nothing there to subtract, our y value is a value of 0. So my center point is x equals negative 3. Y equals a value of 0. My radius should come down to a value of 5. Question you have? Okay, you had some problems deal with the worksheet here. Deals with some of the ideas. Number one sort of is a little bit different. That's fine. You should be able to handle that. Get a graph down, see what it looks like. Tomorrow we'll come in. We'll start talking about equations of lines and working with equations of lines. And continue to go in regards to a coordinate plane into functions and ideas. Questions? Your D is done.